Now, we were talking about three different operations that you can perform on Boolean variables. That means you're changing the values of those Boolean variables, and that means well, there's only one way you can. If you're changing one Boolean variable, there's only one way you can do that. Right? You just change it to the other value, because Boolean variable only has two possible values. But what happens if you have two Boolean variables? Well, then you can perform an operation on two of them. Conjunction, it's sort of like anding of the two of them, and disjunction, that's sort of like an or of two variables. So now conjunction, you just think of con like with junction, like joining, coming together. So a conjunction, or just and. So you're joining two Boolean variables. Now, so let's label the two Boolean variables as x and y. Okay. So the conjunction would be x and A and D, y, x and y, and x has a Boolean value, y has a Boolean value, and the statement as a whole, x and y, also has a Boolean value, and that value will be 1, true, only if x and y both have Boolean value 1. Okay, and in all the other three cases, because four possible cases, x can be true or false, y can be true or false, or if you're thinking in terms of zeros and ones, x can be 0 or 1, y can be 0 or 1. Okay, so there are four possible cases. Starting to talk about combinations, and in three of those, the combination, or the conjunction, x and y, that x and y has value 1 only if x and y, both of them, have value 1. That's why it's called and. Right? Because x has to be 1 and y has to be 1. Right? That's where the and label came from, or conjunction. Right? Now, so the two Boolean variables that you're anding both have to be 1 or true. Right? Now the and, instead of writing out three letters, A, N, D, a short way of writing the and is just this symbol here. It sort of looks like an upside down V, right? That's V, but it's sort of like this. Right? So that's your and symbol. Alright, now similarly, the stuff I'm saying here for conjunction, that's anding. You have a similar corresponding definition for disjunction. Disjunction, that's the long-winded way of just saying or, right? And again, if you have two Boolean variables, let's say x and y, then you can combine them into a new expression, x or y. Okay. Now, what's the value of that combined expression, x or y? Well, it too has a Boolean value, and hence it can only have two values, 0 or 1. So if x is 0 or 1 and y is 0 or 1, what is x or y? This is a combined statement, combined expression. Well, in the case of disjunction, or, it's 1 in three cases, and it's only 0 in one case. And the case when it's 0 is when x and y are both 0, or both false. Right? So if one of the x or y is true, or 1, then the OR of x and y, x or y, will be 1. So if x or y is 1, then x or y is 1. Now if x and y are both 1, x or y is still 1. So there are three of the 4 possible combinations of true and false values. 3 of the 4 give you 1. And the only one that gives you 0, 0 is the value of x or y. So x or y. Okay? Now, instead of writing OR, 2 letters, the disjunction, the OR operation, also has a symbol for it. So it's sort of, this one reversed. So now it looks like a V, capital V. And you see that in the context of Boolean values, and you say, that's the OR operator. Okay? Now I introduce the concept of truth table, which sort of summarizes what I've been saying in the form of a short table of what the allowed values are when you combine variables, Boolean variables. Now the not, so there's three truth tables, three cases, or 3 operations. There's the not operation, there's the and operation, and the or operation. Or if you want the longer term, negation, is that right? Yeah. To negate means to say the opposite of, to not it. Conjunction, put together, and disjunction, or, right? So let a here, little a here, be just one Boolean variable. So the value of this variable can be either true or false, or 1 or 0. Okay. Now if it's 0, and what's here is the result of notting. And remember this symbol here? That means not, N-O-T. In other words, convert to the other value. In other words, so if a is 0, well, not a will be 1. Okay. So that's value 0. That's the value before you not it. Okay. So 0 will become 1. And if a is 1, if the value of this Boolean variable is 1, and you not that, well, you get 0. Right? Boolean variable. Boolean variables can only take 2 different possible values. True or false, 1 or 0, whatever. Okay? Now, AND involves 2 Boolean variables. So let's call them A and B. And remember the AND symbol was this one. So I don't know if you can see that, but that's little a and symbol, like the upside down V, B. So A and B. Right? So if the Boolean variable little a has the value 0, false, and the Boolean variable little b has the value 0, false. So if both of them are false, then A and B is defined to be 0, also false. Okay, and similarly, there's 4 cases. So if A is 0 and B is 1, so just one of them is true, but the other one is false, then A and B is false. So that sort of makes sense. They both have to be true for them to be true. That's why it's sort of and. This is true and that is true. Okay? And if one of them is false, well, the combined, this A and B expression is false. They both, A and B both have to be true for A and B to be true. That's sort of common sense. Okay? That's where this comes from. So if one of them is true and the other is false, like this case and this case, the A and B, the combination, is also false. Now the only way this is true is when both of them are true. When A is true and B is true. 1, 1. Then A and B is 1. Okay? Because both of them are true. That's the nature of AND. This is true and that is true. Therefore A and B will be true, because each one individually, A is true and B is true. Now OR, more flexible. Your statement here, A or B, that will be true if one or both of A or B, A and B are true. Okay? So now if they're both false, A or B would be false. That's sort of common sense. Okay? So if both are 0, A or B will be 0. Like if A is false and B is false, they're both false. So A or B would need to be false. Okay? But in the other three cases, if just one of them, or both, if one of them is true, then A or B is true. So that you can use these truth tables. That's what these three things are called, truth tables. Right? So they're tables of truth, like a list of truths, the results. So these, you can sort of look on these as the inputs, and this is the output, in a sense. So you could imagine like a black box with two inputs, and this would be the output. If you've done any computer architecture or electronic design, you'd know about logic gates. So this might be like a NOT gate. So one input, one output, and an AND gate, a logic gate. You'd have two inputs and one output. And for the AND gate, the output would be one of these. And for the OR gate, two inputs, one output, and the output value would be one of these, depending on the two inputs. Right? So truth tables, very, very useful.